Hi, this is Chris Schomburg, and today we're going to talk a little bit about a push button switch and a buzzer. Now, in this case, we're going to actually talk about the piezoelectric buzzer. It's a PK21N30WQ. Now, it's a lot of a mouthful, but basically it's a polarized, so the key point, it's polarized, and it's a piezoelectric speaker. Now, what that means is that actually it has a crystalline structure to it, could be quartz crystals, that changes shape according to electric fields. And so because of these electric fields being produced in it, it actually changes its shape and then can create a sound wave from that. Now, you can actually use piezoelectric effect in many other applications. My sister actually researched that as her senior design project at Mines. But it's something that you can totally look into and research and do a lot of in-depth research about that. She's a material scientist, so that's kind of a cool thing to actually look into. Again, it's the crystalline changes shape by electric fields and then creates a sound. You can actually change the shape of the crystal. You know, quartz crystals for years were used in watches, and they were actually, you know, they produce what's called almost like a clock signal, like a 555 timer if you're familiar, but basically a clock signal, and they can produce a signal and like a change in voltage almost on a periodic behavior, like basically happening like ticks. And so because it can basically tick tock, like that, it basically, the quartz crystal can do that, and then that's actually can power things. And so that's how actual more modern watches, or you know, the old analog watches actually worked. So that's an interesting thing. You can research it, you can look into more of it. I actually have that on a website that's actually allaboutcircuits.com. It's technical articles on how piezoelectric speakers work. I encourage you to continue and read more about that. Okay, so today's lab, we're actually going to be talking about a couple things. The first is a push button. Well, we've done a push button before, so that's not that big of a deal, right? But we're talking about this buzzer. Again, it's polarized, so it can only have polarity in one direction. And so what I want you to think about, especially when we get into this, is, okay, how can I keep the polarity the right way? And okay, so we talked about before an assembly drawing. Now, today we're going to actually graduate from the name assembly drawing to pictorial schematic drawing, and that's on your left-hand side. You're going to look at that real quick here. And you'll notice that we have a red wire, we have an orange wire or yellow wire, and we have a black wire. And why we have the yellow wire instead of the green wire from last time is this is kind of a signal that doesn't have a large voltage drop. And because there's not a large voltage drop, it's actually what I consider a high signal. So before we had a low signal, it wasn't really that high because there's a voltage drop between the lamp or the light, and so that was a low signal. Here we have a high signal. If you get into digital signals, you'll look into high versus low signals and basically the difference. But for now, we know that if we go across a push button, it's a short circuit. So we know that's truly going to be a high signal coming off of there. So we know that much. So we're just going to use a yellow instead of a black. Okay, so then on your right hand side, you're going to look at the schematic diagram. Again, I'm going to graduate you a little bit here. You should be able to draw both of these. So that's one thing. Before we were just assembling them, okay, from the assembly drawing and from the symbolic diagram, we should be able to assemble them for both. So that was 1 and 2. The third thing I think you should be able to do is draw both of these. Be able to draw and create them from one or the other. So you could draw it from the assembly drawing, or you know, draw it from an actual schematic in that case. Okay, so that's kind of graduated a little bit. We're developing a little bit more of our science techniques here. Alright, so that being said, we've looked at the schematic diagram, we've looked at the pictorial diagram, the symbolic diagram. We know that we need to be able to draw these now. And now we're going to go ahead and we're going to wire this up. So let's go ahead and start by going and grabbing all of our colorful wires. And again, these wires came from online. It's great that our sources, that we can get sources like this online. Again, it's sad that we did lose the Radio Shacks and a lot of the small mom and pop stores, but we're actually getting a lot better deals that's a good thing, right? It's good to also have a lot of other people who are kind of looking into this. So that's a good thing. So now we can actually get these 3 wires. We want a red, we want a black, and we want a yellow. Okay, it's like the German flag. Just remember that. Okay, so we got those. We have the red, we have the black, and we have the yellow. Okay, so what we're going to do is we're going to go ahead, we're going to hook from the negative terminal first, okay? Because we're doing electron flow, and that's negative electron flow, so it's going to go from the ground terminal. So I'm going to set that in the ground terminal right there. And then we're going to go ahead and we're going to hook that directly to the piezoelectric. Notice that there is a positive and a negative. We want that in the ground, so we want that in the negative there. Okay, then we're going to go ahead and we're going to hook up the yellow. In this case, it is a jumper, and so it is a high signal. So we need to be really careful about that. But we're going to go ahead, we're going to hook that from the positive of the speaker, the piezoelectric speaker, to the push button, okay? And we're starting to see our loop here, right? And then we're going to go ahead, we're going to take the last wire, the red wire, from the push button, okay, and then to the 12-volt battery. Okay, so that's to the 12-volt. That looks good. So we basically have a current loop. It's a loop or a cycle or a circuit. So we can see that it's looping from the negative ground rail to the negative of the piezoelectric speaker, then from the positive of the piezoelectric speaker, which is in this case, this is a jumper, from the positive to the push button, and then from the push button to the high voltage or the 12 volts. Okay, so it looks like a loop. That's good. We should be able to then go ahead and power this up. So we're going to turn on the power from the solar. Okay, we're going to turn on the power from the main. We're going to turn on the power from the DC, and nothing happens. That's good, because remember we're normally open at this point with our push button. We're going to go ahead, we're going to go to normally close. There we go. It works for the second that we push it. Now this is a lot nicer than the selector switch, because the selector switch, we would hear that buzz as long as it's selected in this position. So it's a lot nicer to just hear it for a second, and we can press it, you know, eureka, for a second or two if we need to. But that's a lot nicer. We don't actually have it on the whole time, or, you know, off the whole time. So in this case, the push button is probably the preferred selected switch for this case. Okay, now consider the following. This worked because we used the right polarity, right? So for some final points, we actually learned a lot about a push button and switch, as well as a buzzer. Now in this case, this turned out to be a piezoelectric speaker. And the piezoelectric speaker, in this case, uses a crystalline structure, okay? That could be a quartz crystal or whatever. And then actually, by electrical fields, it creates a sound. So it actually changes its shape due to electrical fields, and then creates a sound. And so it actually can produce, and in this case, you can actually change it by either pressing it too, and then you can actually create a electric field as well. So that it's kind of, you can create a voltage from this. It's a really interesting topic. I'd like you to go ahead and research more into it if you want. Again, I recommend allaboutcircuits.com and look a little bit more about how piezoelectric speakers work, and go ahead and read more about that. That's what I would consider that would be good for you to do. We did learn about the piezoelectric speaker. We learned that it's polarized. It can only accept in a certain direction. Again, it's not that it keeps the circuit. It's not that it actually corrects or rectifies the circuit. In this case, what it does is it consumes the power, and it has to be consumed in a certain direction. So it's called polarization, and it has a positive and a negative terminal. If you switch those, it will not work. Again, we can double reverse those, so we can have a double negative, or an inversion, or a reverse and a reverse. But that's not what we want to do. We want to hook this up the simplest possible way we possibly can. All right, I hope you learned more about electronics, and I hope you continue to discover and explore more in science and in electrical engineering.